In this video, we will discuss how to measure the mass in a chemistry laboratory. Before we get started with our measurement, we first need to pick the right equipment for the job. We have two types of balances from which to choose: a top-loading balance and an analytical balance. The key difference between these two types of balances is the precision of the measurement that we can make with them. Top-loading balances usually have a precision limit of plus or minus 10 milligrams, or 0.01 grams, whereas typical analytical balances allow for the mass measurement within plus or minus a tenth of a milligram, or a milligram. To choose which balance to use, we should consider how precise we need the measurement to be. If a high degree of precision is required, such as in the case of preparing a standardized solution from a small mass, then we should choose the analytical balance. However, if precision is less critical, either because we only need an approximate amount of something or because we are using a large amount that can be measured accurately with less precision, then a top-loading balance should be used. If we need to measure 0.055 grams of sodium chloride, which type of balance is our best choice? Only an analytical balance can get us precise masses down to the thousandth of a gram, so we would need an analytical balance for this task. If we need to measure approximately 2.0 grams of sodium chloride, which type of balance is our best choice? While an analytical balance gives a more precise mass measurement, it is not always necessary. In this example, we only need to measure a relatively large mass that is around 2.0 grams, with no requirement for higher precision. Therefore, using the top-loading balance is our best choice. It is faster and easier to use compared to the analytical balance, and it meets our needs for this procedure. Let's now use the top-loading balance to weigh about 2 grams of sodium chloride. Before starting, it is always a good idea to make sure that the balance is in good working condition. First, we should clean the balance pan by brushing it off gently with a brush. This ensures that we do not have any debris that could be weighed in, giving us an inaccurate reading. We should then tare the balance by pressing the tare button. The balance should read 0 after tearing, as the balance pan is empty at this point. The process of tearing is essentially to set the baseline for the mass measurement. Finally, make sure the balance is displaying the desired units of grams. Now that the balance is ready to be used, we can begin our measurement. One important rule to remember is to never add the sample directly onto the balance pan. This could cause damage to the instrument. Instead, we should use a receiving vessel to hold the sample during the mass measurement. This receiving vessel should be lightweight, and the choice varies depending on the type of sample. Options include a piece of weighing paper or a weighing boat for solid substances, or a small beaker or graduated cylinder for liquid samples. What is the best way to add the NaCl solid to the balance for mass measurements? As sodium chloride is a solid substance, a weighing boat is our best choice because we want the receiving vessel to be as lightweight as possible. We only use a small beaker when we are weighing a liquid and have no other option. Before adding sodium chloride to the weighing boat, we should first measure the mass of the empty boat by placing it on the balance pan. Make sure that the balance is tared and displaying zeros before weighing the boat. Record the mass of the empty boat. Then, tare the balance again with the boat on top. Remove the weighing boat from the balance once the balance display reads 0. Upon removing the boat, we notice that the display reads a negative number. What should we do with this reading? In the previous step, we tared the balance with the boat on top, so now that without the boat, the balance is measuring a lesser mass. This is why the balance reads a negative value at this point. Next, we can add the sample to the weighing boat using a spatula. It is important to add the sample to the boat on the side of the balance, rather than adding it while the boat is on the balance. This is to prevent spilling chemicals on the balance, which can cause damage. If it is the first time you are weighing a specific compound, you might not know how much 2 grams is. So it is always a good idea to add samples in small increments using a spatula. Place the boat with the sample back on top of the balance carefully. Wait for the reading to stabilize. Currently, the reading of the balance shows 3.78 grams. What does this mass correspond to? As we have tared the balance with the weighing boat, this 3.78 grams is the mass of NaCl. If we were to tare the balance again with nothing on the pan, we can see that the total mass of the boat, 2.28 grams, plus the NaCl, 3.78 grams, is 6.06 grams. We have clearly added too much NaCl. We only need 2 grams, but now we have 3.78 grams. What should we do? Never ever return excess to a stock reagent container. Never. That's the easiest way to contaminate a lot of chemicals. The correct operation is to remove the excess and dispose of it in the waste. However, as you can see, this introduced additional waste. Therefore, we should always add samples in small increments to minimize the waste we produce. It is okay to measure the mass several times as you are adding small increments. Currently, the balance reads 2.11 grams. What should we do next? Well, it depends. If you actually need 2.0 grams, then you should try to take out a little more solid to get to 2.0 grams. But it is very rare, at least in the setting of a general chemistry lab, that you will need 2.0 grams. So the correct answer is the third one. It is important to keep in mind that it is okay to not have exactly the mass that the procedure is asking for. Your time is more important. If the mass is close to the target, all you need to do is record the actual mass you measured on your lab notebook. How would you record this mass reading in your notebook? The correct option would be 2.11 grams, since the top loading balance measures up to 2 decimal places in precision, and including the units of a measurement is a must for any lab measurements. We're done with our mass measurement. Great job. What should we do next? Before we simply walk away with the measured sample, we should make sure that the balance area is clean for other users. What should we do before we walk away with our sample? All of the above. We should be good lab citizens. The balance room is a common lab space shared among all students, so we should always clean up after ourselves so that we do not impact other students' progress. That's it for the top loading balances. We will introduce how to use an analytical balance in another video.